Amphipotic. Amphipotic defined means a substance they both can donate a proton as acid and accept proton as base. And here I pull up the chart. Strong acid, weak acid, and strong base, weak base. Amphipotic is the one that in the middle. So now let's look onto amphipotic. Remember the definition. It can donate proton and accept proton. Now let's see. Amphipotic, it can work out as a base. According to the base means you can accept proton. You can accept a proton. But when would it be a base? It depends on your partner. If you have a strong giver, a strong proton donator like HCl, you strongly want to give a H+, then amphipotic will be obliged to be as acceptor, accept proton as base. Of the same amphipotic molecule, it also can behave as an acid. What's mean by acid? This time is donating proton to give out the H+ ion. So what determined is also determined by your partner. Example, if you have ammonia, ammonia is a proton acceptor. A proton acceptor, so ammonia is a strong base that you try to gain proton. You try to accept proton as base. Then what happened to the amphipotic? The amphipotic become an obliged giver, giving H+ ion as an acid. So amphipotic is very much based on your partner. You have, in the first situation, you have a strong giver partner, you become a taker. And on the bottom situation, if you have a strong H+ taker and you obliged to be a H+ giver. So are you a giver or are you a taker? Depend what partner you have. Student, do not confuse amphipotic with weak acid and weak base. And people would thought weak acid, do we early say it can accept proton, after accept it can donate? And now let's see this theory. Okay, now let's look onto the acid. CH3COOH. This is ethanoic acid. Ethanoic acid, can you give the H+ ion? Of course, acid can give H+ ion. That is meaning of acid. But if I ask you, can CH3COOH accept one more H? No, you can't become CH4COOH. So now you only can be an acid. You cannot be a base. Now let's look onto a weak base. Ammonia. Can ammonia accept H+? Yes, of course. That is what ammonia do. It is a strong H+ acceptor. But can ammonia donate H plus easily become NH2? No. So you can see in these two situations, they will only work as a weak acid, the other only work as a weak base. Now let's look on to the middle amphiprotic. HCO3, 1-. Now let's see amphiprotic. Can you accept one more H? Once you accept one more H, you become H2CO3. Yes, you can do that. Okay, can you donate one more H? Once you donate one more H, you become CO3 2-. Can you do it? Yes, you can do it. Now, to qualify as an amphiprotic, you need to be able to do both to be amphiprotic. Repeat the definition. Amphiprotic can both be a donor proton as an acid and an accept proton as a base. Now I'm going to show two examples how you're going to construct the equation as follows. The first, HCO3 1-. So on the top one, when you're in a base situation, when you have a base partner. On the bottom one, when you have a strong acid partner. So remember, amphiprotic determining are you acid or a base, it depends what partner you have. On the top one, you have a strong base partner, so you obliged to be an acid. So how will be the equation be? Conjugate pair. If you are acid, your mirror pair will be 1H less base. How about the base OH 1-? Your mirror pair will be 1H more. H2O now become an acid. Now do the bottom example. Now HCO3. Now when this time this amphiprotic met a strong acid, which is a strong H plus giver, donate H plus. So what you become? You oblige yourself to become a base. When you have a strong acid partner, you oblige to become a base. So now using the conjugate pair rule. So this base, your mirror pair must be 1H more. How about the acid H3O? What will your mirror pair be? Be 1H less. Base, water. Now let's do another example. Same situation. When you have a strong base partner, so HSO4 1- become an acid. Your mirror pair 1H less. OH 1-. Your mirror pair 1H more acid. Bottom example. When this amphiprotic met a strong acid, you oblige yourself become a base. So your mirror pair is an acid 1H more. For H3O, your mirror pair 1H less. That's the way you construct the equation of amphiprotic substance. It depends on your partner. So are you acid or base? It's not by yourself, but rather by your partner to determine.